Good afternoon, all. Welcome to HitTalk by Hitcon. Uh, Thank you very much for joining us. As you know, Hitcon is a platform where technology meets healthcare, and we are here today with again one of the leading cardiologists of Ahmedabad, Dr. Kamal Sharma. Welcome, Dr. Kamal Sharma.
Hi, good afternoon, Dr. Pragnesh bhai. Thank you for having me. It's always a pleasure knowing you for so many years, ever since I started my practice. And I'm glad that we are moving into another direction again together.
Yes.
Pleasure.
Dr. Kamal Sharma is a very well-known cardiologist of Gujarat, one of the senior most cardiologists of Gujarat, and I think he has got a special cupboard at his home for his the gold medal number of gold medal that he has received. So again, with an academic brilliance, sir has now ventured into a new domain of technology innovation, which we always want doctors to do because we at Hitcon always believes that the whatever the exciting thing that is going to happen in the next decade in the healthcare is going to be with the help of technology. So we are here with Dr. Kamal Sharma, who has recently innovated a technology for this arrhythmia or detecting early arrhythmia in patients. So in the short journey of 10 minutes, Dr. Kamal Sharma will take us along the innovations that he has done. Welcome, Dr. Sharma, once again.
Thank you. Thank you. Pleasure.
Yeah, Dr. Kamal Sharma, all the doctors are very busy. So the first question is, what was the need of this innovation?
Uh,
Hello.
Watch or a section of irregular. So there was a problem with the wearable technology that currently exists in terms of detection of data set that is studied to develop atrial fibrillation algorithm, what is based on what is called as tachograms, is fallacious in terms of how it detects atrial fibrillation. So your Apple Watch picks up atrial fibrillation based on tachograms of 6 consecutive beats, of which if they are irregular 5 out of 6, you are detected to have AFib. This is the how data set is trained in your Apple Watches or AFib watches or rate watches. The problem with this is that it does not meet the definition of atrial fibrillation that the way we detect, which is 30-second strip. So this is absolutely out of sync. That is number one. Number two, all the data test sets that have been trained in Caucasian population. There is no data set that has been trained in Indian subset. And what's the problem with that? The problem is that our kind of context, that is the problem number 3, in which we do activities very different from the Caucasian. We live in 45 degrees Celsius. We have meals and then have an afternoon nap. We have a very heavy dinner. We tend to have rapid movements. Sometimes we are lethargic. So there is a context in which your rhythms will change. We all know that AFib is slightly depending on context. So when your heart rate would change, when you go from supine to sitting, when you have food, your heart rate will change.
True.
And that context would also be hence changing the tachograms, will change the irregularity or the duration between 2 RR beats. So that So we included these 3 things. 1, the context. 2, the Indian data set. And 3, the what we did is analyze the ECG strips of 5,000 hours compared to the MIT data, which was much lesser, of rhythm strip, which was analyzed between the AI-based model, which was also deep aware in terms of neural network and learning with the data scientists of the team. And we also tried to correlate it with 2 independent cardiologists trying to report what they thought of the rhythm. And then if there was sync between the 2, that only was considered as a true detection by the algorithm. So this algorithm is what has helped us to get the Indian centric data. Number 2, look at the context in which the rhythm is changing. And number 3, in terms of more duration of hours in the Indian subset of patients.
Okay, so this is matlab, you can say uh, it gives a lot of more information rather than the things already available. So basically, the solution, as you have pointed out, is a device could be any, but ultimately, what you have devised is an analyzing solution.
Yes, so this can be integrated with multiple. We can integrate it with, say, Apple Watch, Samsung Watch, or a Chinese model, or Huawei watch, or whatever watch you want to do. Like, or we can use even it with wearable technology, or even with the rhythm strip analyzers, or even the current Holter monitors. You can
Right.
integrate this algorithm, which is based on deep learning and neural network that we have created, which is self-analytical and keeps on learning and upgrading with the time goes by. And we already have 5,000 of hours of data, which is now in the open access. Everybody can analyze and utilize it to, we have not kept it locked up, but we are refining our data set so that it can become more specific for the need that we are looking at in Indian subset of patients.
Okay, and what user you are targeting? Physicians, cardiologists, or something? What user category of users you are targeting?
To be honest, we are targeting this to be integrated in the device, in the industry, in the wearable segment, to be integrated with all wearable technologies, including watches, including Holter monitors, including patches that rhythm monitoring can be done. Because I think the problem is with the algorithms by which the machines pick up these abnormalities. And that is why Tamara be patient, you must be getting patients, and so do we. Okay, my Apple Watch is saying atrial fibrillation. And then you
Yes.
analyze four papers, including one of them in the Frontiers in Cardiovascular Medicine, in a cardiovascular journal called at KEKB paper, and also another one that is Deep Aware paper. So all four papers have actually been peer reviewed, and they're all international accepted databases, including two papers in the computer engineering journals and one in medical journal. And so we are looking at the whole horizon, right from starting from the general public to the cardiologists all across the spectrum.
So I think this seems to be the smart solution because it is not sticking itself to a particular device, but it's an interface. So any device can connect, and a lot of doctor patient, as you rightly said, the industry can take benefit out of it. Great.
True.
And when you expect this to hit the market ready?
So, see, algorithm can hit as early as in, say, 4 6 weeks. But what we are looking at is to have our own background device along with it integrated into it, so they get the technology of interface is also captured by us, because we don't want somebody to come and tell us that their device and our app interface is taking them a problem and it can't be integrated. So if we can show it that any innovative or any simple device that we create can be integrated and the interface is not a problem, then it can get integrated with any device. Like we did this on the mCardia device, which is a Denmark based device, and it could get really integrate. And the algorithm needs to be trained once with the device. Once we do that, I think the deep neural networks will actually auto learn the algorithms and auto refine it to huge extent, and the positivity would extremely go up, false negatives will go down, and hence the accuracy will almost try to reach 100%. So I think we are if we are looking at the device with the interface of our own, then we'll probably look at around 4 6 months. But if you're looking just at the algorithm, it's open access is easily available, but the commercialable part of it to be integrated with other devices may take a couple of weeks.
Okay, and how big do you think the market is?
Wearable technology is a big market. I think I'm the way I see 20 years down the line, you and I will not have phones. We'll be just putting our finger on the frontal head and just doing telecommunication like this. And same way, you will not be requiring a catheter to be put or a blood pressure to be cuffed, to be inflated. You'll be having a patch on your hand, which gives you right from saturations to your metabolic status, to your lactate levels, to your blood pressure, heart rate, ECG changes, and a lot of biomarkers. So I think the wearable patches and technology is practically going to be a therapy or diagnostic and prognostic. Initially, probably more of prognostic for patients who are already getting discharged. You want to put them and see them. But I think it will become universal as the technology becomes cheaper and easily accessible and expands fast. Probably it will be a technology for everyone. So the way I see a healthcare industry moving from prognosis to tertiary care therapy to moving it back to primary prevention and prognostic karta better, it be a diagnostic and evaluative and monitoring therapy. It's like it's going to be, you don't ask who needs to wear a watch. Everybody wears a watch, or everybody at least stays in touch with time. So why would somebody not be keen to monitor their health as they monitor the time? And I think that's where the technology would head 20 years from now. And I think that's why the market is too big. If everybody actually would fall into the candidate right now, of course, we are looking at the segment of elderly, at risk, AFib patients, known patients or suspected patients. But the horizon in 20 years down the line of the wearable technology is going to be probably universal.
Thank you. And one last question. You are a busy cardiologist and all the doctors are busy. What makes you think of doing such an innovation?
I think I always say this, that in India, unfortunately, 20 years back, the top brains would think of becoming doctors. I think all doctors have this capability to be a scientist. It was only that being a scientist was not lucrative enough or socially not acceptable or not encouraged. Right. We all are basically scientists. All doctors are basically trained in a branch of science, and they are inherently scientists. Somehow that fire within us has been subdued by our peer and social environments. I think every doctor who submits a thesis in his MD, how it is done is a different story, but basically he's a researcher. And I think that needs to be cultivated, brought out. And believe me, as they say in West, publish or perish. If you will not now innovate, you will be lost in the ocean of a lot of professionals just flooding our market. There'll be thousands and thousands of super specialists coming every year. There'll be even more generalists coming to the market. And when that happens, what will set you apart is to look into the technological aspects and innovative aspects ethically, in terms of not only practice, keeping this very different from the commercial aspect, and trying to innovate, which is good for public, good for masses, or also ethically correct. If that is something that can be done, I think every doctor needs to proceed in this line and contribute to development of society and country in terms of scientific growth.
Thank you, Dr. Sharma. That was simply excellent. And we would at Hitcon would really like to congratulate you for this excellent innovation and the direction that you are going. And I'm quite excited to hear about a couple of more things that you are working, and we'll be surely have you once more on the Hitcon when the other things are ready. Thank you, Dr. Sharma, for joining today. Thank you all the viewers for joining us at the Hitcon. And if you think you have got some story or some innovation and something to share with us, something to share with the medical fraternity, you are always welcome to the Hitcon. Thank you. Thank you everyone for joining.
Thank you, Pragnesh bhai. Thank you. Pleasure to be with you. Bye-bye. Take care. Thank you.
Bye.